Myself Mrs. H. Fatima. I am from Hindustan College of Engineering and Technology. In this video, we shall see the definition of Laplace transform and the procedure to find the Laplace transform of the function f of t. Now the definition of Laplace transform. Suppose that f of t is a real or complex valued function of the time variable t greater than 0 and s is a real or complex parameter. We define the Laplace transform as f of s is equal to L of f of t, which is equal to integral 0 to infinity e power minus st f of t dt, where the limit exists as a finite number. S is a fixed parameter, either real or complex, when evaluating the integral. Now in this section, we shall illustrate the procedure to find the Laplace transform of the function f of t. In all expressions, it is assumed that f of t satisfies the condition of Laplace transformability. Now let us see this by example. Determine the Laplace transform of the constant function f of t is equal to a. Solution is, using the definition of Laplace transform, f of s is equal to L of f of t, which is equal to integral 0 to infinity e power minus st f of t dt. Now here the given function is f of t is equal to a. So L of a is equal to integral 0 to infinity e power minus st a into dt. Integrating and applying the limits, we have L of a is equal to e power minus st by minus s into a. Applying the limits 0 to infinity, we have a by minus s 0 minus 1. Here e power minus infinity is 0 and e power 0 is 1, provided s greater than 0 if s is real. Thus we have L of a is equal to a by s for s greater than 0. Now let us see this by another example. Find the Laplace transform of f of t is equal to e power at, where a is a constant. By definition of Laplace transform, we have f of s is equal to L of f of t, which is equal to integral 0 to infinity e power minus st f of t dt. Here f of t is e power at. So L of e power at is equal to integral 0 to infinity e power minus st into e power at dt. So which is equal to integral 0 to infinity e power minus of s minus a into t dt. On integrating, we have L of e power at is e power minus s minus a into t by minus of s minus a. Applying the limits 0 to infinity, we have L of e power at is equal to minus 1 by s minus a into e power minus infinity minus 1, which is 1 by s minus a for s is greater than 0. We know the limits e power minus infinity is 0. So finally we get L of e power at is 1 by s minus a for s greater than a. Let us see by one more example. Find the Laplace transform of f of t is equal to cos h at. Now let L of f of t is equal to L of cos h at, and we express the function cos h at in its exponential form. Cos h at is equal to e power at plus e power minus at by 2. Now the Laplace transform becomes L of f of t is equal to L of half into L of e power at plus e power minus at, which is equal to half into L of e power at plus L of e power minus at, which is L of e power at is 1 by s minus a and L of e power minus at is 1 by s plus a. So L of cos h at is half into s plus a plus s minus a by s square minus a square by taking the common denominator. Thus we have L of cos h at is s by s square minus a square for s greater than a. One more example. Find the Laplace transform of f of t is equal to sin h a t. The solution is L of f of t is equal to L of sin h a t, and now we express the function sin h a t as in its exponential form. Sin h a t is equal to e power a t minus e power minus a t by 2. Now the transform becomes, Laplace transform becomes L of sin h a t is equal to half into L of e power a t minus e power minus a t. So which is equal to half into L of e power a t minus L of e power minus a t. We know L of e power a t is 1 by s minus a, and L of e power minus a t is 1 by s plus a. And by taking the common denominator, we have a by s square minus a square for s greater than a. Thank you.